Hello. So this is um, a short or a mini review for our test two. It's three questions, well, four questions, but two of them I'm only going to do half, so it kind of adds up to three. All right, first thing, notice the number 10. So this one is the 10th question in the review in MyLabs Plus. Find the area of the shaded region. The graph depicts the standard normal distribution with mean 0, standard deviation 1. So they're kind of nice. They both tell us it's standard normal and they give us the mean standard deviation. All right, well, the shaded region, is this turquoise area right here, right? So this is the area that's less than z equals 0.69. There's a less than, right? There's no lower limit. If there was a lower limit, it'd be minus infinity, right? Okay, so in the calculator, that's normal CDF. We use our favorite substitute for minus infinity. For me, that's minus 4 nines, comma. Then the upper limit is the 0.69, comma, mean 0, standard deviation 1, and out comes 0.7549. Right? Remember, this area is the probability. So the probability of a randomly selected number being less than, having a z-score of less than 0.69 is 0.7549. You're going to use the Excel equals norm.dist. Remember, norm.dist by default gives you the probability of being less than the number you put in the first spot. So that's what this question is. So we just put the 0.69 in the first spot, 0 for the mean, 1 for the standard deviation, and then this last spot here, remember this is for our continuous functions like the normal and the t, this is always a 1. And out again comes the same answer, 0.7549. All right, next question, number 6 in the review. Find the indicated probabilities using the geometric, the Poisson distribution, or the binomial distribution. So this one and the next one both start that way, but they have different specifics. So here's the specifics for this one. Assume the probability that you will make a sale on any given telephone call is 0.22. So they're telling us there our P is 0.22. Find the probability that you, A, make your first sale on the 5th call. So this is about your first sale, right? In other words, it's about your first success. And anytime they're asking about your first success, that tells you it's geometric. All right. Now, there's two different functions on the calculator. If you want the probability that x is less than or equal to a number, you use geomet CDF. You want the probability that x equals a number, geomet PDF. You put in P the probability and then the number of the trial of the first success. Like this first one is make your first sale on the 5th call, right? So the probability then it equals 5, that'd be the PDF, right? You're going to put a 5 in here, and we already got the P is 0.22, so that's the way that would go. Second one here, make your sale on the 1st, 2nd, or 3rd call. Well, that's less than or equal to 3, right? So that'd be a CDF. The probability of success is still 0.22, but then we want the probability of being less than or equal to 3, so we just put a 3 in there. Now, if you want to do this in Excel, this is kind of the oddball where Excel does not have a geometric function, but the geometric is a special case of something called the negative binomial. So in Excel, it's equals neg binom.dist. First spot, you put in the number of failures. So like in A here, first sale on the 5th call, that would mean 4 failures, so we put a 4 in there, right? Always put a 1 in the second spot, that's the number of successes, and for geometric, it's always 1. P is our probability, in this case it would have been 0.22, and then in the last spot, in Excel for all of these discrete ones, you either put in 0 for PDF style if you want the probability of being equal to the number, or if you want probability being less than or equal to the number, you put in 1. Okay, and so again here, the kind of the other twist with Excel, the number of fails ends up being 1 less than the success, right? So probably success on the 5th call will be 4 failures, etc. All right, so let's move on down to the next one. Like I said, this one starts off the same. It's the same thing. They want us to pick between geometric, Poisson or binomial. A newspaper finds that the mean number of typographical errors per page is 8. Okay, so right now we know this is probably Poisson because only the Poisson cares about the mean. Find the probability that exactly 6 typographical errors are found on a page. All right, so we've already seen up above that geometric is when they're asking you about when is your first success. You're going to do something until your first success. How many times are you going to do it? That's geometric. The binomial, okay, for the binomial, well, they're going to tell you we're going to do this n times. There's going to be n trials. We're going to do this n times, and then x is the number of successes in those n attempts, okay? Now, the Poisson, similar to the binomial, x is the number of successes. In this case, we get this odd situation where, I quote, success is a typographical error. But there's no set number of trials. It's just on a page, in a unit of time, something like that, okay? So these things, this is Poisson. Again, either just because it's got the mean or because it's asking for the number of successes and doesn't tell you how many trials, how many attempts. All right, Poisson PDF and CDF. The PDF and CDF mean the same things they did before. PDF means x equals to the number. CDF is x is less than or equal to the number. Poisson, you put in the mean and then the number, right? So for A here, it's exactly 6, right? Well, it's probably exactly 6. So the mean was 8, and we'd want the probability that we had exactly 6 successes, we'd put in a 6. For B, at most 6. Well, that's the same as less than or equal to 6, right? That's the CDF, right? And the mean's still 8, and then since it's 6 again, we put in 6, but this time it'd be the CDF, and it would get us less than or equal to. All right, if you're going to do it in Excel, equals Poisson.dist, it reverses the order of the numbers, put in the number first and then the mean, and again, 0 for PDF style, 1 for CDF style. All right, let's move on to our last one. This is number 37 in the review. This one was pretty widely missed. I'm going to guess it's because of a little twist. You'll see this here. Find the margin of error for the given values of C, S, and N. I'm going to guess it's largely missed because they just give us S here. And you have to remember what S is. S is the standard deviation, right, for a sample. Right? So in other words, we don't have the standard deviation for the population, we've got it for the sample. That tells us this is a T. So our error term is going to be our TC times our standard deviation of S divided by the square root of the sample size. All right, so our TC is going to be, all right, we need a couple other things first. So the confidence level is 0.9, so 1 minus 0.9 divided by 2 is 0.05. And then for the T, we're also going to need the degrees of freedom. And you remember the degrees of freedom is n minus 1, right? So in this case, that's 29 minus 1 is 28. Okay, so now we're going to put this in the calculator is INVT 0.05. Our degrees of freedom is 28. Remember, this is going to come out negative. We're just going to drop the minus sign. Technically, put the absolute value around. In any case, it's 1.701. If you wanted to do this in Excel, you would get TC equals absolute value T dot INV. And in this time, the numbers are exactly the same in the same order. And we would get the same 1.701. All right. Now we're ready for our E. Our error term is 1.701 times. Our S here was 2.8. Our N is 29, so it's over the square root of 29. And you put this into the calculator, and out comes 0.88, and then, a bunch more digits, 88. The question asks for it to 1 decimal place, so this rounds to 0.9. right, that's it. I hope you found that helpful.